Lesson 5. Independent events and the product rule. Two events are independent if the outcome of either event has no effect on the outcome of the other event. Okay? So, example, a coin is flipped at the same time a die is rolled. Okay? If you think about it, flipping a coin and rolling a die do not affect each other at all. Okay? If I pull something out of a hat, all right, and then I don't replace it, and I pull something else out of a hat, that first one affected the second one because now there's a different number in the hat. So these are two things that don't affect each other. So the probability is 1 out of 2 when you roll a die, and 1 out of 6, 1 out of 2 when you flip a coin, 1 out of 6 when you roll a die. We're going to multiply these and get 1 out of 12. Okay? They don't affect each other. So here it is. The product rule of independent events says if you're looking for the probability of these two things happening that are independent, you just simply multiply each probability. So, number 2, the probability that Natasha does her homework is 3 out of 5. While the probability that Boris does it is 1 out of 5. What is the probability they both do their homework on any given day? That's just 3 out of 25. You just simply multiply it. Now, number 3 is a little bit different. Same numbers, 3 out of 5, 1 out of 5, but what's the probability that neither do their homework? Well, we got to think about that. If 3 out of 5 is her doing it, 2 out of 5 is her not doing it, 1 out of 5 is him doing it, 4 out of 5 is him not doing it. I'm sorry, 1 out of 5 is him doing it. Yeah, 4 out of 5 is him not doing it. So we're going to take these two fractions, these two probabilities, and multiply them and get 8 out of 25. The probability that she does her homework again is 3/5 and him doing it is 1/5. What's the probability that only one of them will do it? Okay, this one's a little more complicated. So if you see one like this, you just gotta break it down. There's a couple situations here. Only one. That means Nat was a yes and Boris was a no, or Boris was a yes and Nat was a no. What we have to do is look at these two different situations and then add them together. So we're basically going to take 3/5. So we're kind of mixing these up. We're taking, whoops. Okay, why does it keep doing this? We're taking the 3/5 and the 4/5. So yes and no. And then these two. All right. So we're going to take 3/5 times 4/5 plus the 1/5 times the 2/5. All right. And what this is going to give us is 12 and 2. So that's 14 and then 25 on the bottom. Okay. So that's the only one that's kind of tricky. You got to look at both possible situations. All right, this is the same thing we talked about before about rounding. If you get a decimal answer, just round to the 4th place. Okay, 60% of the sophomore class are female, 0.6. 80% of them drive, 0.8. 90%, 0.9 of males drive. If one student is randomly chosen, what's the probability that it's a female who drives? Okay, so in that case, female 0.6 times 0.8 who drive. That gives us 0.48 or 48%. Now 60% of the sophomore class are female. We already know that. If one student is randomly chosen, what's probability is a male? Well, we got to go back here. That means 40% is male. So in this case, we're going to take 0.4 times 0.9. So same as the previous problem, except we just didn't have this piece of information. We needed to calculate it, which is 0.36, which is 36%. You might think, why is it lower with there being more male drivers? You got to remember, there's more females in the class than males. So that offsets it. All right, same numbers again. What is the probability of that is someone who drives? Okay, well then we're just going to take the two previous numbers because we know 0.48 is the female drivers plus 0.36, which is the male drivers. So 0.84, 84% are driving, or, would be driven, someone who drives if it was randomly chosen. And then what's probably not being a driver? Well, that's just simply 1 minus the 0.84, because 84% is the drivers, so 0.16 or 16% will be the probability of pulling a non-driver. And that's it.